Okay, so can you guys hear me?
Yes.
Okay, so we're doing like we tried to do the shooter and the
Your
arm.
screen isn't
So
sharing anymore.
um, is it working now?
Yes, I see it.
Yeah.
So it'll pick up a note from the intake. I think whichever intake should work. It picks up the note around here. Then it can turn to shoot it into the I forgot what it's called, the thing above, or it could turn a little more and shoot it into the amp. It's still a work in progress, so if you see any discrepancies, it's because we haven't really gotten to like really like put in all the details. So we'll do that later, but this is like the general idea.
Say that this is something that the new members have been working on almost entirely on their own. Like, they've gotten a little bit of guidance from me, Dragon, maybe. But other than that, this is like something that they've cooked up on their own. It's pretty cool.
So is it using the one-sided flywheel concept that someone put on the
Yeah.
Yes.
Yes. We saw it from the team. We looked at the dimensions, and we decided to go with that.
Did we have we tested that yet, or does it need to be tested
It's
by ourselves?
it still needs to be tested, but this is just a CAD mock-up of what we thought should work.
Okay. Yeah, maybe if we're not able to cut some things out at Lamar, and if we cannot build anything, we may just test the one-sided flywheel to see what happens.
And we need to on this CAD we still have to add motor mounts and other stuff like that. But yeah.
Why don't we stick with the roller system, the dead axle rollers, for the indexing into the shooter instead of using the small wheels?
We can do that. That shouldn't be too hard of a change.
So one major design question: do we need to have this gigantic arm in order to shoot into the amp? I mean, that's the only purpose of this arm right now, to be able to pivot and shoot into the amp.
I'm not too sure. It just like it needs to have like the correct angle to shoot it into the amp. Maybe we could like make the arm smaller if like we can find something that makes it smaller, maybe like change where it's mounting, but this is like the idea that we have so far.
Seems to me that the important chunk to be made is the shooting mechanism and that index mechanism by itself. I have a feeling if we can fix it in one point in space and just be able to change the angle, we may be able to shoot into the amp without needing this gigantic arm setup. Does that make sense?
Yeah.
Does it go out of the size limit right now when putting in the amp, or is it just at like a very high angle?
I can measure it.
This is like the first time this whole like literally 10 minutes before this meeting was the first time this arm was mounted to the drive base.
Let me measure it right now.
Yeah, that's fine. Just one.
So here's another idea. I don't know how many people have looked at the EveryBot amp mechanism. It's essentially just a roller that intakes from the human load station and then deposits into the amp. If we had that mechanism to do the amp, and then we just fix the shooter for the normal high shot, do we even need to rotate the shooter?
I think the main benefit of that rebot one was that the note is kind of precarious, right? The note could fall out if you just move too fast.
Yeah, it
Yeah,
was.
it looks that if you get hit while traveling with the node, you're definitely going to drop it. It doesn't have enough strength.
The
Yeah.
robot also does not fit under our requirement of driving under the stage. So that like, we can't copy it, right? Like we can't straight up copy it right now. I don't know if we have another system that could take it, like deploy it, and then pull it back down. Get under the chain, or under the stage, then it could work too. I haven't seen any like. I haven't seen any like videos of how easy it is to take off or put on. You know what I mean? Like I haven't seen any evidence of it like really falling. You know, it could look precarious, but it could still like work. Right? It could be precarious. It could look precarious, but it could still like be reliable. But you know, it's something that we have to really look into.
Maybe one of the promising designs was in the West Coast Products competitive concept. They had their flywheel kind of more in place, and they had the cover that would go on top of it to shoot in the air.
So actually, we slowed down that video, and when we watched it back, we didn't see the note ever bouncing off the like flywheel guard or anything. Like it was just shooting into the amp fast enough that it angled down and pushed into the amp hole. Like it wasn't necessarily like an actual mechanism.
Oh, so was the shooter just aimed towards the wall of the amp?
Yeah,
It was
and
perfect. It just remember when we did Cranberry Alarm stuff, they were like, oh, maybe there's some configuration of speed and angle that makes it shoot in straight into the amp. They found that speed and angle is what they did, and it worked at least once.
Yeah. Maybe we don't have to find the speed and angle, and we can do something similar to what I assume.
Yeah. No, I'm not sure. Like we've seen one video of them shooting once, right? And it worked. I don't know how many like the reliability on that. From what we've seen, the note was halfway hanging out when they did the amp shoot. So I mean, I'm not sure. Right? That's something we have to try out.
And another.
Let's pick our priorities, guys. We're mostly interested in shooting high right now. So let's try to get all the system to work where we can intake and shoot. And if we have to just fix the shooter right now and have a different mechanism to move it later, I'm fine with that.
Well, I mean,
let's-
even
let's
this
just
could
test
be
it.
fixed.
Yeah,
This could
so-
be fixed in place, and we could add a way to move it. But there's nothing wrong with this geometry. It's just it's going to be able to score in the amp if we want to move it. If we don't want to move it, you don't have to change anything basically.
Yeah, so at the resting position, it's angled at the angle to shoot into the amp, actually. So, and with some fin angling, we can change that angle. Like, I think it's a variable in CAD, so we can just quickly change it.
Yeah, I think the resting should be shooting.
Yeah.
In the main goal, not in the amp.
Yeah.
It's almost, yeah.
Oh yeah, if I said amp, I meant speaker. The rest position here is for speaker shot.
I think another thing a lot of the mentors are concerned about with the big arm thing is I think when they're saying like, oh, let's keep it more static, I think they're talking about the length of that pivot, right? It's more like it's not so much like, oh, keep it, this can be fixed, right? That's great and all, and we can move it later, but we can move that point that we're turning it at really, really closer to the shooter part, so we don't have to deal with the crazy big arm, right?
Yeah.
If
Thing.
yeah. But if you were to put it in place, there's nothing, it's not going to tip the robot or anything. It's just going to be, it's going to be out of the way of everything else,
But I think we as well would not like to deal with a big floppy arm. Yeah, so.
Well, in some matches, we might just decide, okay, let's just simplify, have a way to fix it, and we'll just decide not to have too many, complexities if we don't have it all working. So what other systems do we have? Let's try to kind of get it all in one CAD. Do you have more stuff that you want to talk about, Sid, with the climbing?
We haven't really talked about the climber yet, but the idea for the climber is just have it mounted on a through-bore rev gearbox underneath this electronics panel. Let me share my screen really quick. So the idea is that the climber mounts underneath this belly pan and have our winchlets, like the motor runs, like there's one Neo down here with the through-bore gearbox, and it has one side of the winch on this side of the robot and the other side on this side, and those are the spools, and then the wire runs up through the arm, and it runs along the arm, and then once we want to hang, the arm drops the hooks off on the chain, and then we do the pull up with that. But we haven't really gone into depth into the arm, like the climber stuff, just because we didn't know how the packaging would work with the arm. It's still at the same like spot in terms of CAD as the like Team 1 version 2 climber.
So there's no elevators. You're just using the moving arm to set the hooks.
Yeah, if we have the moving arm, that allows us to do that. And I think that's one of the benefits of the moving arm, just having that. And then I think the other reason that we wanted the moving arm was so that we could take shots from not just right up next to the speaker, just because it's like we wanted to be able to do that. I don't know if we'd actually be able to do that though.
Packaging a winch in the electronics is going to be a challenge.
Mm-hmm.
And we're trying to get the electronics together and finalize. So you're really going to need to have a more finalized CAD so we can get the electronics finished up and not have to redo the electronics after winch CAD is done. So if that's the direction you want to go, we're going to have more detail in the CAD.
Okay. Yes, sir.
Now, does anyone have any problem with that direction? I mean, there's lots of ways to climb, so let's hear it out and try to figure out what direction we want to go.
I don't fully oppose like the winch thing because I've seen a lot of winches in FRC, right? Most of the elevators that like the 50-watt elevator is technically a winch too, right? Stuff like that. But my concern right now is you guys were debating about this in the slide channel in this but let's say we're pulling down. I think the big what if here is where are we gonna put the winch, right? So by moving the winch down, because in order it's the same question at the trap too, is to do the trap you need the winch really really low, because you need to be your bow has to go really really high up, and for that to happen, the winch has to be all the way right now under or on the it's really that area, and I think our concern is in order for us to do the trap, in order when we start putting the winch in that area, we're making a lot of sacrifices. We're making the now. Have you seen our belly pan? It was like there's the front part, and then it went above, and then so you can fit the winch under, and it's not covered. Or before we had a really small 2-inch gap for the winch, stuff like that, right? And what we thought was, what me and Cedric thought was, what if we just like took the winch thing and put it above the on that arm superstructure. So, but then I'll put it on the we're gonna have a superstructure for the arm. So put the motor there. So move the electronics. You won't be able to pull out pull down as far. So you probably won't be able to do the trap, but it would probably make us so we don't have to resort to doing weird stuff with like how we're doing it now. But I think that's a big thing.
I will say one thing. Sorry, go ahead, Les.
Oh, so I was going to say there's a team that actually has 2 separate motors for the left side and the right side because they were not sure. They like to control the position on the chain, and in a way it would get rid of a little bit of complexity. You'd have to have 2 gearboxes and 2 different Neos, but it may prevent running through the middle of your robot with anything. Just put them on the side.
Hmm. I will say though, in terms of the belly pan thing. Okay, so the first thing with the belly pan, like the reason that we split up the belly pans wasn't because we needed space for the winch to go down here. It was that we didn't feel like a need for there to be a belly pan here. If we still wanted a full length belly pan, we could put the electronics underneath the winch and that would still work. And then in terms of like moving the winch onto the superstructure for the arm, what if we put the electronics on the superstructure of the arm? Like instead of putting the electronics at the bottom of the belly pan underneath the arm and then having the winch over here, put the winch in the bottom of the belly pan arm and then have the electronics on the side there. Like
We've put on the brace, between, you're going to have a brace like a triangle.
yeah.
Yeah, so we've put on each side, we've put different electronics.
A one-piece belly pan is pretty critical to having your frame not rack, if that makes sense. You need a belly pan. Kind of an open square frame like this is not very strong without a plate on the bottom to keep it from twisting. So separate panels is not the greatest of ideas. I mean, aside from being able to cut them on a smaller machine, that's fine. But one piece is the best way to go. And I'm still wondering why are we so focused on having all the electronics on one panel flat in the robot? I mean, this is a pretty open frame we have. We can line the interior walls with electronics. I discussed angled panels. If that a slight angle isn't good enough, it could be 90 degrees. There's plenty of space to put electronics in this frame. I don't think there's any reason or need to put them on any sort of superstructure.
Yeah, I already kind of CAD'd it. I don't know if I put like my thought process in the CAD of making like a sort of like a slanted panel on both sides where we put electronics. I calculated it and then the length between like the length that we have was like near 8.5, nearly 9 inches. And if we were to extrude it like 8 inches, we would have like a lot of space for electronics. I think the only like big concern is putting the PDH even closer, even more to one side, and making wiring maybe a bit more difficult. I think that was one of the concerns with that. Because I mean, the nice thing about the angled, the slanted panel is you could probably just put the winch in the middle and it would work probably fine.
Well,
Yeah.
exactly. You don't have to worry about putting it under the plate, over the plate, and wire is pretty cheap. We can put cable ducting all around the robot. We can run long wires. It's not the end of the world to have a bunch of wiring.
I was gonna ask actually, for cable ducting, would it be like just put zip tie holes and then zip tie like cable ducts down? Like, how would we plan for that in CAD?
Well, there is literally a product called cable ducting, which is a C channel with grooves in the sides. So you would run your wires through this ducting, and when it needs to exit, it exits through a slot in that C channel.
That's cool.
So it's this plastic channel. So you would secure that plastic channel somewhere, and so we could literally have a run of this going all the way around the robot, so that it reaches every major component.
Another
So
thing
is the-
about the sorry, go ahead.
Oh, I was just wondering. So is the issue right now that a spool plus gearbox plus motor is too big to fit low on the robot? Is that the issue we're discussing?
Kind of, sort of. It's just like the overall packaging issue of a winch at the bottom of the robot and then having the electronics in that same area. But I think like if the conflict is electronics and a winch in the same space, the electronics can be reorganized around the winch.
Yeah, kind of like you have the vertical plate for the Spark Max, right?
Yeah, exactly.
I think. Also, I think the 8 inches. That's like the 8 inches of length that we have. That's pretty conservative, I think, because when I calculated this the other day, it was I gave up like 10 inches of space for the winch, thinking there was going to be two neos for like the actual gearbox. But since it's one, like, that can probably be even longer. So we're looking at maybe 10 inches, probably more. So I have plenty. Uh, or what would we make this out of though? Would it be like 1/8 inch polycarb, or
What part?
for our electronic panel if we were to make it slanted?
We could even make them out of acrylic so they could be laser cut. It's not too critical of a part.
Okay. But will that be able
All
to
right, we
like
got about
bend?
10 minutes left, guys. So let's talk about priorities. Lamar has the mostly finalized drivetrain, and a lot of swerve modules need to be, attached to that and wired, meaning the connectors for Andersons need to be done, which is going to take a lot of time. So let's make sure we have people always working on that and doing it correctly. Go ahead, Sid.
Two things. The first one, I think we were gonna have a code update from Adrian and the other code guys, and then the second thing, I know that we have for Andersons. I know that we have a bunch of Andersons at Westside, and we forgot to get the awards from Lamar this weekend. So if we could like orchestrate a little trade at some point before like Thursday, that would be ideal.
Yeah, that's fine. Work it out. Should we do the code update real quick, and then we need to talk a little bit about other priorities that need to be done?
Okay. Yeah.
Sure. Yeah. So I'll talk a little bit about code updates, what's happened, future plans as well. So in terms of code, through some testing over like the past, I'd say 2 weeks, just from testing code on the Swerve at Lamar, we realized that another priority that we didn't initially really consider with code is making sure all of our control systems and our robot is functioning properly and to the best of their ability. So essentially, all the stuff like PID, feed forward and feedback loops, things like that. That is one of the priorities that we've really discovered, and this will essentially the goal of this is really to make sure that our robot does exactly what we want it to do, and even though if there's some like minor errors when building the robot, so maybe some dimensions are a small bit off, which can cause the robot to do things slightly differently. We can correct for this in code, in software, by really making sure our control systems are as optimal as they should be. So that's one thing. That's one thing that programming team is going to do more of and in the future. And also in terms of what's been done, we've been working a lot. Well, we've been looking into control systems, and also as well as, and I think me and Kyle have been working on. Well, mainly Kyle has been working on getting Advantage Kit and things integrated into our robot. Essentially, getting back as much data as we can from the robot as possible. So things like robot pose, for example, and also like swerve module states, things like that. Getting as much data back from the possible from the robot. So, for example, if something goes wrong, if we need to quickly test something, or if we need to debug an issue, let's say during competition, we have a quick and fast way to do that instead of physically looking at the robot and wasting time doing that like we did last year. Instead, we can use code to specifically grab data, grab things from the robot, and be able to debug quicker that way. And I did want to mention vision because I know that's been something that's been talked about. I know it's been something that's like, hey, if we have vision, we can do so many more things. It'll be better and easier on the drivers. And while yes, I agree, that is something that would be useful. It's less important we've talked about it within the programming team. We think it's less important than messing around with control systems and getting data from the robot. It's less important than getting the robot functioning to the best of its ability. And so we're putting that off until after we figure out all the control system stuff and things like that. Also, one more thing we are going to continue doing in the future is writing some basic like template code for some subsystems. So the hope is when all the subsystems are built, we have some kind of template code or something that we can hopefully run the subsystems on as quick as possible, so we get that tested as soon as it's built, hopefully. And if anyone else has anything to say regarding programming, then yeah, that's quick programming update.
Thank you, Adrian. You guys are doing a great job. Westside, you guys need to really buckle down on CAD and figure out this electronics winch climbing stuff and try to get like close to full finalized CAD.
Sounds good.
And I don't know if you guys want to start taking apart your practice frame and try to match it down. That's a lot of work. I think CAD's more important right now. So it kind of depends on how you guys are progressing with CAD before you start cutting apart the swerve test frame.
We also have a lot of students that can't CAD and can't program either, so I'll just make them do that stuff. I think we'll get it done.
Okay, yeah, let's just get it down to 17, but watch it carefully as you do your first cut, and you know, it's going to take a little bit of supervision.
Yeah.
What other priorities do we need to get done? Either school.
Maybe testing the flywheel at Lamar, like the single-sided flywheel, getting the compression number down and ready, and just kind of having everything in a spot where we can kind of throw something together on an actual robot. Maybe get some field elements assembled, like a mock-up of the amp and the speaker.
Yeah, Carl and Chris are talking about that. We'll let them handle the timeline on that. For now, I think Lamar's got lots of work to do. Westside's got lots of work to do. So I think you guys have plenty of things. Just try not to get too distracted with stuff that isn't critical to getting, you know, the full CAD finalized and to really start building all the right pieces that we need, because we almost are going to have two robots that are going to be pretty similar at each school.
One thing.
Can we get?
Sorry, go ahead.
Go ahead, Sebastian.
I have all the components for I have all the 3-inch wheels. If you guys are gonna make something with the flywheel, I'd have to hand them over.
Yeah, I mean, you hold on to what you have right now. We'll order more. So I guess this is the next priority that actually is very important. Everyone needs to be sending me what they need. So make a priority tonight to look at what's important to you and send me a list, because we need to do a lot of ordering to keep up with what we're going to need to build this robot. So that's actually a pretty big priority for me to do, is to make sure we get stuff ordered. So if you need something, yeah, start sending it to me, please. And so assume, like, if you're in the shooter and we're pretty certain that we're going to use 3-inch wheels and you need more, send me how many more you need, Sebastian. And same for, you know, we're having 2 robots, right? We kind of know some of the pieces that we're already missing. Let's think about just getting some more and having extra.
Okay.
At some point, can we get a consensus on like what the heck we're gonna do with the like top half of the robot? We're gonna see. We talked about like just like literally half an hour ago about the arm thing. I feel like we're at that point where we have to get a consensus on that next week.